You've been introduced to the three trigonometric ratios, sine, cosine, and tangent, and you have worked with the sine ratio. Sine is opposite over hypotenuse, or the length of the opposite side to the acute angle over the length of the hypotenuse. In this video, we're going to focus on cosine. Cosine is the length of the adjacent side to the acute angle over the length of the hypotenuse. And our third ratio is the tangent ratio, which we will cover in another video. So as was just stated, cosine is adjacent over hypotenuse. And as you should usually do with any triangle, is you should identify how the sides relate to the angle. And in this particular triangle, it has already been done for us. So we are looking at angle A. So I'm going to circle angle A. And we are looking at the adjacent side and the hypotenuse. And remember, hypotenuse is always directly across from the right angle. And the adjacent side is the other side that forms that angle. So for cosine of angle A, the adjacent side is side AC, and the hypotenuse is side AB. So the ratio for the cosine of angle A would be the length of AC over the length of AB. Now let's practice this. So for cosine of angle A, again, let's circle the angle, and let's identify the hypotenuse across from the right angle. You may have also noticed that the hypotenuse is always the longest side of any right triangle. And then remember, directly across from the angle is the opposite side. So that leaves the remaining side to be the adjacent. Again, it's the other side that forms the angle we are working with. So for cosine of angle A, remember cosine is adjacent over hypotenuse, A over H. We're going to be looking at 36 over 39. And we want this in simplest form. Each of those numbers is divisible by 3, so this reduces to 12 over 13. And the directions are also asking that we round to 3 decimal places. So that is approximately 0.923. And we get that number by taking 12 and dividing it by 13. Now let's take a look at if we switch this up and we find cosine of angle B. So that's going to change which side is opposite and which side is adjacent. It's not going to change which side is the hypotenuse, because the hypotenuse is the same side no matter which trig ratio we are looking at. So angle B, this time opposite, is going to be the 36. So that means the 15 is the adjacent. And again, cosine is adjacent over hypotenuse, A over H. So this is 15 over 39. Again, both of these numbers are divisible by 3. So this reduces to 5 over 13. And as a decimal rounded to 3 places, that is 0.385. Let's take a look at one more triangle. Let's start with angle R. Again, I'm going to identify the hypotenuse first, either as being the side across from the right angle or opposite of the right angle, or in the longest side of the right triangle. And then we have opposite of angle R, or across from angle R, is the opposite side. is 18, which means the 80 has to be the adjacent side. Reminding ourselves that cosine is A over H. So our adjacent is 80. Our hypotenuse is 82. Both numbers are divisible by 2, so this reduces or simplifies to 40 over 41. And as a decimal to 3 decimal places, we have 0.976. And now let's take a look at cosine for angle S. Again, the hypotenuse is still the hypotenuse. That is not going to change. What is going to change are the opposite and the adjacent. So angle S, across from angle S is the 80. So that's our opposite, which makes the 18 the adjacent this time. So the adjacent is 18, the hypotenuse is 82. Both numbers can be divided by 2. So we have 9 over 41 as our simplified fraction. And as a decimal, this ends up being something like 0.2196, I believe. So when we round it, it has to be rounded as 0.220. So we have sine, cosine, tangent, which we often hear it as so, ka, toa. We have covered sine, which takes care of the so. We have today looked at cosine, which takes care of the ka, the A over H. And we will be looking at tangent, the toa, in a video to follow.